Hello guys, welcome you all to AI Ki Pathshala. I am your host Anup, and in this session we are going to discuss DataFrame drop NA. So let's discuss. So you can see my title here. I have one thing, I have made this file day16.ipynb file, and as usual we used to create import these two libraries, and this is a Toy DataFrame that I have created. So I am pinging you all this Toy DataFrame. You can also use the same data frame so that when we will be working on the same data. And those of you who are watching the recorded session, you can just pause the video and just write down first these Toy DataFrame. Fine. So when we were working with series, then the drop any method, at that time we have used the drop any method, and that the drop any method excludes all null values from a given series. And in data frame, it does exactly the same thing. But now it comes with a few additional benefits, or you can say some additional power. Most importantly, with data frames, we could specify the axis we want to draw from. So let's look at this example here. So this is the same Toy data frame that I have used in the previous session. Now let's run this first line of code, then run this Toy data frame, and let's see what is my DF. So this is my DF. Can you see here? If you remember, it has 4 rows and 3 columns, and currently it doesn't have any null values. So what I will do, I will first start by inserting null values here. So let's insert some null values. So I'm writing df.log, and I'm taking my index 2 and column weight GHT. That means at this index and at this column, weight column, that is at this position, I want to insert some null values. So how I can insert? I am writing np.nan. So this will insert the null values. So let's run this code. Fine. Now again, if I check my data frame, let's see what I am getting. DF, if I check my data frame, I am getting this null value here because I have inserted one null value at this position. np.nan I have done. Now let's say I want to change an entire row. Let's suppose I want to change this row number 1, this row. I want to convert this entire row into the NaN values. So what can I do? I will again insert the NaN values in the entire row. For that, I will write df.loclog. Thereafter, this time the row number is 1. The index for the row number is 1 index. And what is the name? Because now this time what happens is that since I want to insert NaN in this entire row, so I have to take the entire column starting from first column to the end. So for that, what I will do, I will simply do this thing. I will add colon. It means it will start from the first and it will go till end. And thereafter, if I write np.nan and run my code, let's see what happens. And let's again see our data frame and see what changes it have been made in our original data frame. So can you see initially this row is having some values, and now this row is having NaN because I have inserted NaN inside these rows. So now this is my data frame now in which I want to work upon. So here what I am doing, You can also see np. I am using np.nan. That means I am using numpys. I'm not using a number object. So we have an entire row set to nan. So at this point, we have a data frame that have at least one nan. If you check all the column, you will see we have at least one nan in each column and at least one nan in column number, in row number 2 and row number 1. If you will check the row number 1 and 2, you will see I have at least one NaN in all of the 4 rows. So now let's see how this drop NA behaves with this data frame. So we will begin by specifying the methods, drop NA methods. We will take the drop NA methods, and initially I am not specifying any arguments inside this method. So my method is df.dropna, drop NA. It is there. Just select it from here. Just select, and I am not passing any argument. And let's run this and see what happens. So what we will get back is a data frame, and that data frame excludes all rows, or you can say all records, which contain at least one NA. This data frame excludes all rows which contains at least one NA. So the row of index 1 which contain only NANs is gone here. And so is the row of index 2 which contains one NAN is also gone. So the only rows remaining are those labeled with 0 and 3, which contains no NANs at all. Now, this will be a bit restrictive if drop NA always work like this. And fortunately, this is not the case. So initially I have used this drop NA with no parameters. But there are 2 parameters which are currently set to their defaults, which drive this behavior. Already I have not given any parameter, but still there are 2 parameters which are set to their default values. So using this drop NA without any argument, as we are doing here, is same as saying, let me write it here, is same as saying df.dropna, and inside this there is one parameter called how. So by default this parameter is set to any, any, comma, and there is another parameter called axis which is by default set to 0. So if let's say I will run this code, I will get the same thing which I am getting here. Because these parameters, there are 2 parameters, how and axis, and these parameters have been set to their default values. So the axis parameter, I hope we all are familiar. We have read about this many times. So it is used to indicate the dimension or axis through which we want the method to operate. So axis is by default set to 0, which is the row axis. 0 means row axis. That means when we want the drop method to exclude rows instead of columns. So what we want, when I have set this x parameter to 0, this means I want this drop NA method to work upon the axis rather than upon the row rather than the column. So when we say, we mean this sequence of values, be it a row or a column, depending upon the axis we specify, should be dropped in its entirety if any one of its value is nan. Any means whatever be the row, either this row or this row. If any value inside that particular row is my NaN value, or if all the values inside my particular row is NaN, then that row will get dropped. When I am setting this axis as any, in that case, fine. Axis any parameter shows it will drop that particular row if any value inside that row will be my NaN values. Fine. Now you can see this has 3 NaN and this has only 1 NaN, but both get dropped. Now, so both they are meet this criteria of any condition and so they are dropped. Now, another possible value for the how parameter is the all. So let me copy this code, paste it here, and let's change my parameter from any to all. Now, let me run this code and then I am going to explain you this thing. Now, can you see earlier 2 of my rows was getting dropped, but this time only 1 row was getting dropped. Why is it so? Because this time I have set my how parameter to be true. Now only those row which is having all the values as NaN, that row is getting dropped now. If you see my original data frame, only this row which has an index of 1 has all the 3 values age, weight and height to be NaN. So that's why only this row is getting dropped. Otherwise 0, 2 and 3 indexes are intact. Fine. So this is how this is the difference in the working of the any and all. All will work when all the rows, if you are taking axis is equal to 0, if you will take axis is equal to 1, then the same things applies for the column level. Now it is applying for the row level. Fine. So this all parameter will work will work when all the row values will be my NaN, then that rows or that column will get dropped from my data frame. Hope this is clear. So the how parameters allows us only 2 options. This how parameters allows us 2 options, any and all. This is to be remembered. Now, after this, here, after this, there is another one thing is that one parameter is there which is called thresh. So let me write it here. This is called THRESH. Let's understand this thresh. So when we say what is this thresh and how it is working? So thresh is nothing. It's another parameter that allows us to fine tune this dropping condition that we are using this condition. So this thresh parameter allows us to fine tune this dropping condition. Now the thresh is a short form of for threshold, and it gives us an opportunity to specifically say how many non-NaN values we want in a given sequence. So let me write it here so that it will be clear for you. This will say it specifically says this thresh it specifically says how many non-NA values or non-NaN values, non-NaN, how many non-NaN or non-NA will be better, non-NA values we want in a given sequence. So let's understand it. So let me first use this parameter here and then I will explain you. So let me write df dot drop NA And let's use this thresh thresh parameter. And I'm giving it 3. And let's set axis is equal to 0. I am taking axis is equal to 0. And let's run this. Can you see? I am getting this row 0 and 3. So this is, if you understand this stress thing, this is a bit of a reverse condition. Whereas with the how parameter, we specify the exclusion criteria. In other words, condition for what should be dropped or excluded is including in the how parameter. But here, with the thresh parameter, we define an inclusion condition. So we are now specifying the minimum number of non-NaN values. Let me again write it. Minimum number of, let me write it here. Minimum number of non-NA values for the record, for the record to be included. Fine. So this is all what it means. So when I am writing thresh is equal to 3, minimum number of non-NA values for the record to be included. So if you look at my original data, if you look, let me here check df, let me access this df so that it is good. So if you look at this df, what is the minimum number of non-NaN values here? This 0 row is having 3 non-NaN values, and this 3 rows is having 3 non-NaN values. Apart from this, these 2 rows is having NaN values. Either it is having 3 NaN values, this is having 1 NaN values. But only these 2 rows is having the minimum 3 NaN, is having minimum 3 non-NaN values. That's why I am getting this thing here. Hope you understand this. Now let's do one thing. I'm going to write, let's just copy this code from here. And if let's say I will write here like this, instead of this thresh, if I can also use like this, this df dot shape, 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 and let's access one. If I will do this, again, I will get the same thing. Hope you understand this thing also. Because what is my df dot shape is there. Let's see. Df dot shape. If I access this df dot shape, what I will get? 4, 3. So I'm accessing this 4 from here. 1, sorry, not 4, not 3. Because 1 I am putting, if I will put 0, then I will get this 4. So I'm putting 1. So this is 3. So instead of specifying this thresh is equal to 3, I'm using it like this, df dot save, and I'm accessing the first index of this value, save value, which is 3. So I'm getting the same result now. So what it basically means, this is dynamically sourcing the length of our column axis of our data frame, and we set them that as the threshold, and these are guaranteed to align itself. So here we are saying that we want this dropping condition to be applied to the row axis, because we are putting axis is equal to 0. So we want the rows to be excluded, and the threshold for non-NaN values is set to the maximum. So we want to have as many non-NA values as this data frame, as there are columns in this data frame. Fine, because there are 3 columns and I want 3 here. I'm putting 3 here. So remember, the shape object for data frame is a tuple. You can see here, it's a tuple. that contains two values, the length of the rows, the index axis, as well as the length of the column. Fine. Now, so you have understood this thing thresh, how we are using. Now, let's see what will happen if I will write, let me add few code cells here. Fine. So what will happen if I will write here df dot drop na, and this time if I will put my axis is equal to 1. I'm putting the axis parameter is equal to 1. And let's run my code. What I'm getting actually nothing but my row level. That is 0, 1, 2, 3. So why I'm getting this? So what's happening here? So basically we got back an empty data frame. It has an index only, but it has no columns. So that's because the how parameters defaults to any. And our original data frame has nan in all the columns. If you can see my original data frame, or if you can access the original data frame here itself, what you can see here, the how parameter is set to default value, that is any. Here the by default drop access parameter is any, and if you and my access is 1, so now it will, instead of checking it in the row, it will going to check in the column. So if you look at the all the three columns, every column has at least one NaN values. So it is dropping this column also, it is dropping this column also, and it is dropping this column. So all the three columns are getting dropped. That's why I am getting an empty data frame. I am getting nothing here. Hope you understand this. So if you, let's erase this thing, and let's do one thing. Instead of this thing, if you will use here how parameter, how is equal to any, still you will get the same thing. This is just for your understanding. Still you will get the same thing. So let's access. Can you see? Still there is no changes. Now there's one thing also. If I will change this how parameter to all, because how has got two values, any or all, so we can use this thing. So what will happen in that case? So let's also see this. If I will use axis is equal to 1, and if I will use how is equal to, let's say, all. So in that case, what happens? If I run my code, I am getting all the columns. Now, why I am getting this time all the columns? Because this how parameter says you will drop the column in which all the values is NaN. But here, if you see the three columns, there is no column here which is having all the NaN values inside it. That's why it is not dropping any column, because it is not fulfilling this all condition. It is fulfilling the any condition, that's why it is dropping here, but it is not fulfilling this how condition, that's why it is not getting dropped. So I'm getting my original data frame as it is intact. This is fine. Now let's do one thing. Now again, I'm going to use here axis is equal to 1 and use this thresh parameter. thresh and is equal to 3. That means I'm applying the thresh parameter on my axis. So what does the thresh parameter says? First remember, my thresh, this thing says that if I apply thresh parameter to any one of my column, so I require minimum, if I'm putting this thresh is equal to 3, what means I require minimum 3 non-NaN values. So if you look at this column, age column, can you see there are 1, 2, and 3 non-NaN values is there? If you look at this height column, 1, 2, and 3 non-NaN values is there. But if you look at this weight column, only 2 non-NaN values is there. So ideally, I should get this age and height. So let's run and see. Can you see I'm getting this age and I'm getting this height column? So hope you understand this thresh thing. So here I have did, I have combined this thresh and the axis column. So you have understood this thing. Now, one last thing to note is that everything we did in this session returns a copy of the data frame. So all these data frames are copies of this DF. The DF remains unchanged. As you can see, DF still retains unchanged because we are getting a copy of the values. But the drop method is one of those methods that supports the in place parameter. But so if we set in place to true, sure enough, the changes will be carry on. But here we have not set the in place, and by default, my in place parameter here in the drop method, my in place parameter is false. That's why nothing is getting changed in my original data frame. So this is all for the today's session. In the next session, we will understand a subset with this drop NA. So see you in the next session. So let's do one thing. Let me commit this code to GitHub. Drop NA method discussed with Toy data. Fine. Let's commit this code. Yes. String changes. Thanks, guys. Thanks for coming. Keep learning, keep smiling. See you in the next session. Take care. Bye-bye.